Guten Morgen. So today I want to show you how to create a turbo module with Codegen. It's not super difficult, but the steps are fairly long on the documentation. And I thought a visual guide would be a lot easier to process for a lot of the community. So I'm just going to start by creating a new repository. So a new React Native app. So I'll just call this awesome TurboModule 3 because I spent some time trying to do this. And I'm also going to use TypeScript, which Codegen now supports very recently. And as long as this is completed, let me move this. I'll get right into it. So while this installs, let's just go over some basic points. Once again, for the community, turbo modules are only meant to lazy load your module, right? It's not going to give it any superpowers. It's not going to make it faster. It's just a different way of loading modules. So previously, all the modules that you created in your app, they all load on application start. So that might make it a little slower, especially when you have too many of them. And turbo modules solve this by lazily initializing the modules. So I'll just go inside this folder. I'll open VS Code just for me to show it to you. So just a normal React Native application, and I'm also going to open Xcode. Oh yeah, so today I'm just going to cover Xcode because I haven't taken a look into Android yet. Maybe I'll do that in a different video. I think the setup there might be a little bit more complicated though. So on Xcode, give me 1 second. I'll just open the folder, or I'll open the Xcode workspace. Okay, so here's Xcode. I'll just run the app to make sure that everything is working. Another important point while also this building, so turbo modules I already covered. Code generation is the other point that's interesting. Right now there's not that much documentation. There's only some examples. But basically, Codegen will take a TypeScript file now. It used to take only Flow. Now it also takes TypeScript, where you write the definition of your functions, and will auto-generate some code, some bindings for you. And when you are writing your module, you only need to fill the spaces, so to say. We will see it's not foolproof. You can still mess it up, but it's definitely better than completely manually writing, right? At least you have some sort of type recognition, some type errors in case you don't implement the same types. So it's really cool. One limitation I know of right now, though, is that Codegen is only generating Objective-C and Java bindings, right? So if you want to implement a single C++ code base or a single C++ binding, that's not working as far as I can see. Maybe I'm wrong. So you basically have to bind from Objective-C or Java to C++. Unlike all the previous videos where I'm making, where I was just initializing one C++ binding, a single binding on both platforms. That seems to be a limitation right now, but it might change very, very soon. They're about to release this, so hopefully everything will work out. So here's the app. It's running. I haven't done anything to it. So the first thing that I would like to do, and just to explain it to you how this is supposed to be working, I'm going to go into the app Delegate. This is on the latest version of React Native, and oh wait, let me check one more thing. I need to make sure that this is on 68.1. Maybe it works on previous versions, but this is the version where I tried it, and it actually does a lot of nice things for you. So if you take a look into the app Delegate, you will see that there's some macros now. So for example, this if RCT new architecture enable, it does a bunch of stuff to set up Turbomodules for you. And this is exactly what we want. On a lot of the documentation before, this had to be done manually, you had to overwrite it. But now once this flag is turned off, everything will be taken care of for you. So this has to do with initialization of Turbomodules, of Fabric, and there's also some new functions in here. So this, for example, RCT app setup default root view. If maybe we can take a look, yeah, here inside you can see it's also macros, right? So if you have this flag enabled, it will use the new Fabric object to initialize the UI of your application. If not, it will use the old allocations. And this kind of happens all over the app. Once you have set up the new architecture, these methods to kind of take care of the basic complexity of you. At some point, you might need to get rid of them, of course, or modify them somehow. But for now, this is really nice. This means you only need to take care of this flag. I won't go into too much detail of what these methods do, also because I don't understand them myself too well yet. But basically, they just kind of bootstrap all the Turbomodule system and also some parts of Fabric. Okay, so that's out of the way. We can start implementing our module. So the first thing that I'm going to do, I'm just going to go into the pod file. And I'm going to turn on some things. So first of all, I don't want Flipper, just it makes it slower. If you don't know Ruby, I did Ruby many years ago. This file changed, and this tells you change false to true, but this is no longer false, blah, blah, blah. So this is just a map, and you can do flags. And this kind of notation, this is just using a symbol, right? So instead of using a string like this, in Ruby you declare a symbol like this. And there's just some minor performance optimization, or maybe major performance optimization, but it doesn't matter to us, right? We can just write it like this, Fabric enabled. So I'm going to turn these two things on, Hermes and Fabric, which are necessary for writing the Turbomodule. I'm also going to install Codegen. I think it might be already packaged within the latest version of React Native, but I want to install it anyways, just in case it's not there. And I'm just going to build the app one more time to make sure everything's still working. Great, so there's one detail in here. You may think, okay, I have turned on Fabric and I have turned on Hermes and everything's working now. But if you take a look, this flag is a different flag, right? So I could put in here, and I mean, let's just do it to try it. So I'm going to export IOStream, which is from C++, the library to do IO operations. And I'm just going to print something. Hello from new arch. I'm just going to print something to make sure that everything or the new architecture is running. I'm going to rebuild the app, and let's just see what the output is once this is finished running. And you can see my string is not here, which means it's not enough to turn on Fabric on the pod file. We need to add this flag. Sorry. So I'm going to do these changes, and I'm going to take this flag. I'm going to go into my project, build settings, and I'm going to search for other flags, or just flags. And here I can see on other linker flags, or maybe I can also do it here. We can also do it in the custom compiler flags, I think. and other C++ flags, there's a bunch of flags for Foley. Foley is one of the native libraries that React Native uses. And here I'm going to add -d, the new arch enable, and I'm going to add a 1. Right, and let me just put this back to make sure that everything's working. Let's just compile it. And now you'll see I got an error. It basically is telling me I don't know, or I cannot find this header file. And this is exactly what we want. This means that this flag is now turned on. So the other thing I'm going to do is I'm going to install the pod file, but I'm going to add, 1 second, install, let me just look at RCT. I'm going to reinstall the pod file, but this time I'm also going to add the flag in here. So RCT new arc enabled 1 npx pod install. And basically this is also telling Cocoa Pods to kind of do the new architecture installation, right? So it will install different versions of the stuff. It will start Codegen, Fabric, RCT, blah blah blah, Hermes, all this stuff which we need to compile our application. So I'm going to run it again. And now it will compile a bunch of different stuff. It will definitely find these headers because now they have been installed via Cocoa Pods. And now our application should be running Fabric. Okay, so the app compiles. And now if we look at the logs, we see hello from new architecture. So we are done with the setup of Turbomodules and Fabric, right? So everything is running. So now we will try to generate our module. So I'm just going to go to VS Code, and inside of the iOS folder, I'm going to create a new folder. Wait, do I need to do this? No, so let's do it via Xcode actually. So this part is a little bit confusing. So you need to be careful. The first time I did it, I messed it up. So I'm going to create a new group with folder. And this one I'm going to call the calendar module. I'm just going to use the same example that they used on the documentation. So I have calendar module, which is an Xcode register group with a folder. And it should pop up here on the iOS folder, calendar module. And inside of this, I will create a new folder. This doesn't need to be on Xcode because Xcode doesn't understand JavaScript. It's called JS, and here I'm just going to say native calendar module.ts. So this is going to be a TypeScript file. I am just going to take, give me 1 second. I'm just going to copy and paste one thing, and then we can go over it. So basically this is how you define your spec for your native module. All right, there are some imports that you need to take from React Native. So namely the Turbomodule interface or the type and the Turbomodule registry. So you create an interface that extends the Turbomodule type. This read-only constant, blah, blah, blah. I mean, you can read the documentation to really know what this does, but I'm guessing you can export some constants from the native side. I haven't used this yet. And then you just declare your methods, right? So I'll just declare one create calendar event method that takes 2 strings. For now, it does nothing, but at some point, you know, it might return as a different type. It might be async. I just created one test method in here when I was testing it, but I don't need it. And then you just do a default export where you call the module registry, the Turbomodule registry. You pass your spec and you pass a name, right? So Codegen is going to take this definition and it's going to generate the bindings out of it. So we have that. And now we also need to tell Codegen where to find this module, right? So my package.json, at the end of the file, I am just going to append this entry, Codegen config, libraries, the name of my module, what type of auto generation you want. So you can not only generate modules, you can also auto generate fabric component. I mean, not the component itself, but scaffolding for the component. So then I need to tell it where to find the spec file, and this is via this property JS source directory, and basically it just goes to iOS calendar module JS. I mean, this could be TS as well, I guess, but doesn't matter. And now I am just going to run npx. Oh no, wait, sorry. One more thing I need to take care of before I auto-generate this. I need to create a pod spec for it. So I am just going to call this the calendar module pod spec. Let me just copy this stuff. This really you can just copy and paste. This is also on the documentation page. It just basically tells Cocoa Pods, you know, what dependencies it needs to kind of auto-generate your folder. And some of these flags are important, like this folly flags. The name, of course, you probably want to change it, and so on and so forth. Okay, now I'm going to run, where is it? RCT, blah, 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 pod install. And here you will see, this is the interesting part. It not only discovers our package, it will also probably discover a bunch of internal packages of React Native. But the most important one, or the one that we care, is this calendar module one, right? So it means it has found it. And now if we go back to Xcode, yes, read from disk, we will do one other thing, which is on this root folder, and this is very important. I'm going to right click on it. I'm going to add files. And here on my project, I am on the iOS folder. I'm going to go to build, generated iOS, and I should be able to find this calendar module folder. And these are the Codegen auto-generated classes. So I'm just going to add. Right now you get two folders. I know it's confusing. Maybe the documentation will change at some point. But basically here are the auto-generated classes, right? So Codegen has taken my module definition and has created this header file. And here you can see my method. You know, it's a void, it create calendar. It takes a string, a location, and then some other glue code. Inside of the generated Objective-C file, you can see there's a JSI function in here, which will invoke an Objective-C method. So this is what I meant. I haven't seen any way to, I mean, there's still a JSI function, but I still haven't found a way to generate the C++ only bindings, right? That this generates Objective-C binding, which calls an Objective-C method. I mean, you can write C++ on it, but for Android, it will generate Java JNI methods, which I guess is fine for most of the libraries. I mean, if you want to do a double implementation, you want to implement stuff first in Objective-C and then in Java, you might not want to, right? Like I prefer to write a single code base on C++. Okay, so these are the auto-generated classes. You can change them, it doesn't matter, they will get auto-generated every single time. So we need to create our implementation of these files. So on the calendar module group I created, which right now is empty, here I'm going to create a new file. I want it to be a header file. I'm going to call this, so I cannot call it the same, there's going to be conflict, so you probably want to, I mean, you can change the names afterwards, but I'm just going to call it RCT calendar module. That's the convention. I'll add it to the target just to make sure. And this is going to be my header file that implements the generated one. And it's fairly simple. It only contains the import of calendar module H, which is the generated one. And then it just extends an NS object that takes the calendar module spec, right? So this spec is part of the of the stuff that gets exported from this file. And then I'm going to create another file again inside of the folder that I created, which is going to be an Objective-C file. Yeah, we'll rename it afterwards. This again is called RCT calendar module, but this is going to be my implementation. I'm going to change the extension of this to MN. So this makes it not Objective-C, but Objective-C++, which is needed. And I'm just going to copy this, and we'll go over the code. So the first thing that I'm doing is I'm importing my header file, some RCT log. This one I don't need. And basically, this Objective-C, this is just the implementation of this interface. And inside of here, I'm kind of using this old macros from, normal React Native. I'm just telling export a module and export a method that's called create calendar event, takes a name, takes a location, type of a string. Here should go my implementation of the file. And this is the important one. You need to implement this method, which says get TurboModule, get some param, return some pointer. And inside of this, we just make a share pointer to a native calendar module spec JSI, right? And we just pass the params. So this is, as far as I understand, where all the type safety happens, right? So this is what I meant. Here's you create your calendar, but you still declare your params yourself. So it could be that your spec doesn't match your implementation. So this should throw some error at some point if things are not synchronized. Okay, I think that's all we need. Let me check one more thing, which is the C++ language dialect. So here you can see it's 7.14. As far as I know from my tests, this needs 17, but maybe I'm wrong. Maybe it just needs 14, but I'll just bump it up just in case. Okay, and now we can just try to compile this and see what happens. Okay, so the app compiles, it starts, and that's really all we want. So now I'm going to go back into the JavaScript side. I'm going to go into my app.tsx. And of course, this is just the default template. There's a bunch of stuff here that I don't need, I don't want. So I'm just going to delete this, and I'm going to create a button, just a normal React Native button. The title is going to be click me on press. So here's the interesting part. I'm just going to go native calendar module. VS Code auto imports this for me, but I'm just going to show you. It's going to import it from the iOS calendar module, JS native calendar module file. So basically our TypeScript file. And this already has the types that we have created, right? So I can call foo, bar, etc. Okay, so I'm just going to delete all the code that I don't need, that I don't want. The styles, but I'm still going for my app. Okay, so this is basically all we need. So now if I go into my application, I'm just going to reload just in case, and I click on it, nothing seems to happen. But if I look at the native log, it says pretending to create a native event foo at bar. So basically now we have bootstrapped the Turbomodule, right? So this module, in theory, it can be undefined, right? Just because it's decoupled from the application start. So that's why it has this type. You need to make sure that it has been properly loaded. But basically, until the moment I call it, it's not in memory, right? So the moment it gets imported and the moment I try to initialize it or try to do something with it, then it will get loaded. And that's it. That's how you create a Turbomodule with TypeScript Codegen. Now, there are a bunch of stuff that I would like to do, I need to explore yet. So for example, like I mentioned before, how to create a pure C++ Codegen. As far as I took a look into the code yesterday, a brief look, and it doesn't seem like it's supported right now. It seems like it only generates Objective-C and Java bindings. Of course, you can call your C++ from there, but not ideal. The other thing I need to explore, and hopefully somebody from the community will help me very soon, is not embedding this Turbomodule inside of your application, but packaging it as a library. I will also be exploring that maybe in another video. And just in general, how far can this system be pushed, right? There are still some open questions, but the setup is, as you can see, is not super complex. You can start using it in your apps. Maybe you'll get a nice speed bump from turbomoduling some of your modules. So that's cool. Just as a quick plugin, if you would like to support me, you can buy the JSI guide or the C++ guide for JS devs. It's something I wrote, which would help you write C++ code. You can also write, or you can also check out some of my other applications. So for example, Messer is this native tool to convert images. It's really nice. So let me just create one image. I can just, it's gone. I can just drag and drop into my menu bar, and here, I can just prepare stuff to post on Twitter, for example. So I can add some padding, I can add some background. It's super fast, it's super native. I think it's super cool and useful. All right, so that's it. Enjoy and take care.